In this lesson, we're going to continue our unit on an introduction to statistics by talking about populations and samples. All right, so when information is gathered about a group, that entire group is called a population. But sometimes if you're looking at a population, say all the teenagers in America, that's going to be extremely difficult or impossible to test. So oftentimes researchers will study just part of that group called a sample. So a sample is a representative part of a population. Now, there are two different kinds of samples. There's a random sample and a convenience sample. A random sample, members of the population are chosen at random. That gives each member of the population an equal chance of being chosen, and a random sample is more likely to be representative of a population than a convenience sample. A convenience sample is just simply based on doing a testing on the members of the population that are conveniently available or readily available. Such, if you're testing elk for a disease, then if you just test the elk in a wildlife preservation area because they're readily available, they're easy to get to. Okay, so but that is not as representative of a population as a random sample would be. Okay, so when we do that, okay, so let's look at which would better represent the entire population. And it says justify your answers. So the sampling method says that Maria surveys only the band students that she knows personally, and 84% of them want blue uniforms. All right. And John writes each band student's name on a card and questions those students whose name he draws, and finds out that 61% of those want blue uniforms. So which one is a better representative of the entire population? Well, it's easy to see that John's is a better representative because he chose his students at random. Okay, and Maria only surveys the band students that she wants, and they may very well all agree with Maria because they're her friends. Okay, what that is called, that there's a name for that called a bias. BIAS. That's a bias. If it leans towards a certain direction, okay, or if it's not a fair representation. All right. So a bias sample does not fairly represent the population. A minute ago, we talked about surveying or testing the 50 elk that belong to a breeder. Okay, that could be biased because the breeder's elk would very likely be less likely to have the mad elk disease than the elk in the wild. All right. So determine whether each of these three samples down here can possibly be biased or not. So the mayor surveys 100 supporters at a rally about the most important issues to be addressed by the city council. Is that biased or is that not biased? Well, that one would be biased because he's only surveying the supporters at a rally. Okay, he doesn't take into consideration the people that did not come to the rally or that are not supporters of his. All right, so that's a biased sample. All right, second one, the principal sends out questionnaires to all the students to find out what kind of music students prefer at dances. Well, that is what we call unbiased. Okay, why? Because he sent out a questionnaire to all of the students. So he tested the entire the entire population. He didn't even look at the sample. It was the entire population. Okay? And the owner of a record shop surveys only the customers over the age of 18 who shop at his store. Well, that is obviously biased because he doesn't even think about the people that are the teenagers who are, or even younger people who are under the age of 18. Doesn't take that into any consideration. All right. So the whole purpose of testing, of finding a sample and testing a sample is so that we can predict how that's going to look in the larger population. So the principal of a school with 1,500 students estimates that about 400 of those students will attend a band festival on Saturday. A random sample of 25 students shows that 6 of them will attend. Determine whether the principal's estimate is likely to be accurate. Well, to do that, we write a proportion. So we write the ratio of attending to the total number, of students. So when we do that, the sample says 6 out of 25 are going to attend. The entire population is 1,500, and the principal estimates that this up here, the total number of students attending, should be 400. So let's just solve it and find out. So we're going to call that X. All right. So we're going to say 6 times 1,500 should be equal to 25 times X. So 6 times 1,500, 6 times 1,500 is equal to 9,000. And then we're going to divide by 25. I'm going to divide that by 25. And we end up with 360 according to the sample. So is the principal's estimate accurate? No, not exactly. It's not, because he is estimating that more people will come than actually is shown by the sample. The sample shows that it'd be closer to 360 people that would come. All right, the owner of a large chain restaurant like McDonald's or Wendy's or something like that with 1,200 people, 1,200 employees, estimates that about 250 employees will ask for winter vacation. A random sample of 40 employees shows that 8 of them will ask for the time off. Well, so that's 8 out of 40, which actually, if we reduce it down, that's 1 out of 5. Is equal to 250. Well, let's do the X over 1,200. All right, so we end up with 5X is equal to 1,200 divided by 5. And X is equal to 1,200 divided by 5. And is 240. So that's 240, which is very close. That's very close to the number of employees that they estimated. So that would be a fairly close estimation. All right. So that's just an introduction to what we're going to be working on down the road. Make sure that you copy those notes down from the beginning of the lesson here, and make sure you ask questions if you have any, and we'll talk to y'all later on.